are back with Stuart Kent,
Hello.
Android developer and iOS developer at Detroit Labs. Both, all the things.
Still mostly Android. And
Mm-hmm.
I would say it's 75-25 at this point.
Yeah,
It's been a while since I was on an iOS project.
Stay on the light side of the force, man. We all know.
Slowly,
what's better.
people are coming that way from the company. No one's going back the other way. Just
no,
saying.
No one's going Android to iOS.
Once you go Android, you never go back.
What is it? Is it the verbosity of Java? Like, what is it that... Is it just because Xcode sucks?
So I think that Java is like the only thing now that is worse about Android.
Like
Swift
Java.
Java's okay, but it's showing its age a little bit now, especially given the fact that you're limited to Java 7. And Kotlin solves a lot of these problems for you, but Kotlin has still not reached the level of acceptance within the Android community that, say, Swift has for iOS, which is obvious because it hasn't got like Google official backing, whereas Swift is like Apple's favorite child right now. So yeah, so that's the only thing I would say is better about iOS. For me, it's writing in Swift.
Is it Java? You don't like anymore?
I have definitely.
It's
When
a
I
really
was,
nice store, though. You'll come back to it.
I still think it's a great starter language. I think it's a great starter.
It is a good start.
I think I call it the vanilla ice cream of development languages because it's not offensive, but it's also not that exciting. Yeah, exactly. If you're going to start out, you can't go wrong with vanilla. On the flip side, once you develop some taste, then you're like, well, vanilla kind of boring.
Oh, okay, so now that you've gone insulting. Okay, so let's move forward. So, Stuart, what's your background? How did you get into this? Because you've had a non-traditional route.
Very non-traditional. So, let's see, I was in the UK, I did my undergraduate degree in maths, and then I came to America.
He's not faking the accent, it's real.
It's real, it's real, not just for interviews. Undergraduate degree in maths, and then I did a PhD in applied math. That took like 6 years, and I've been in Detroit ever since then. And I was kind of sick and tired of doing math by the time I finished with that. Research is okay, but it takes like so long to get anything done. Like months and months and months of work. And especially in mathematics, you can put months of work into a proof, and at the end of the day, it's not true. So, wasting your time. So I was like looking for something with a bit more sort of tangible output. Yeah, which is kind of why I like front-end dev more than back-end dev, because I like to see the thing they built here.
Right on. So how long have you been a software developer?
Professionally, like 3 and a bit years.
And who is the favorite student that you ever trained?
Oh, I would say Kate was a really good
Catlin.
student. Yeah, this one right here. She was a really good student. That is true. I'm lucky that I've been able to work with lots of excellent people at Stuart Labs, but Kate was very good.
Yeah. And so I'm lucky enough that Stuart and his wife flew all the way to Colorado to hack with us this weekend, which is fantastic. And we were lucky enough to benefit from their ridiculous amount of knowledge. I think you two might have been the two most experienced on the team.
Probably the two most qualified, like two most educated.
Yeah, that's true.
I don't know if education counts for that much. Once you're like,
world,
once you're 3 years into a job, I'd take the 3 years experience over like qualification and anything.
Especially in software, for sure. Cool. So you came into this team and we were working together with the Android. We built it native, thank you very much. And as we were going along the way, we were working together with an iOS developer, and we wanted to share questions that would be the same between the two apps. So he went ahead and built a locally stored JSON file of those questions. So that was the first time I'd worked with a local JSON file. So can you tell us a little bit more about why it was good to have that local JSON file instead of just like, I don't know, an array of strings?
So the fact that it's easily shared between the two platforms is kind of the big thing we were going for, right? So in general, when you're developing software, developing to a specification that you've agreed on with the other side of the party is very important. And for us, a lot of the time in the mobile world, that means that the specification we're defining is between the front-end mobile app and the back-end server. But in this case, we were still trying to share, have two things use the same interface. So even though it was two front-ends consuming the same JSON file, it still made sense to have like a schema in place that we both were building to the same target.
Right. And part of it too is that we weren't sure what those questions were going to be at the end of the day.
Right. So
we were building at the same time as the UX people were.
Exactly. Yeah. So we weren't able to just like write those questions into the app as is. So we developed. The schema was capable of sort of describing the questions that we would ask, the types of questions, the types of responses that we might expect, and so we could build around that structure without necessarily building around the implementation. Perfect case of interface versus implementation. Didn't care about the implementation, built to handle the interface, and then we just subbed in the implementation at the end, and it worked.
Yeah. So part of the problem with sharing a JSON file is that then we have to figure out how it goes from JSON to something usable.
Yes.
So tell us about this tool that we pulled in to do that.
So we used a website called, I think it's JSONSchema2Pojo. So there's lots of like weird words in there. So JSON being the representation of our question structure.
Right.
JSON schema is actually a slightly more formal way of describing JSON. So what we actually did was take like raw JSON that would be like an example response. But there's also ways you can sort of use JSON itself to describe what's a valid representation of this particular object in JSON. So for example, you might be able to describe things like reused types. You might be able to describe which fields in the JSON are allowed to be null or empty.
Yeah.
So JSON schema is like a slightly higher level representation of structure. Luckily, this website also allows us to just give like an example JSON file and try and infer the schema from there. So that's what we did in our particular case. And then the 2Pojo is sort of the two plain old Java objects.
Well, that's what that stands for.
Plain old Java objects, yeah.
Okay.
So rather than us having to write manually Java objects and getters and setters, serialization code and deserialization code, through all this nested structure, it generated those classes and their appropriate relationships for us.
And it was multiple objects that it created from that.
I think we generated 5 different types.
Yeah, we can take a look at that.
Which isn't huge, but it's still a significant amount. This is a hackathon. We don't have time to be sitting around writing Pojos. That's the boring part of it. So getting that out of the way, and also allowing, as the schema was changed a little bit over time to handle different things, we could just regenerate and minimal code changes, minimal time.
Right. And there was one minor, part of the problem with working with outside tools is there's always room for bugs. So there was one minor bug that came up. We had like a miscreated object.
So I would say it's not really a bug. It's a limitation, and it's a limitation that was sort of our own fault. So when I was describing earlier the difference between like a JSON example and a JSON schema, this would have been a perfect case where the schema would have allowed us to work around the issue that we ended up running into. So what we had was an object type that could contain copies of that same object type, so it could be nested indefinitely. So the idea was that we had a question type, and within that there could be follow-up questions, and those questions all had the same structure. But because we weren't using this schema, it was trying to infer, what the object types were supposed to be from just a raw example, and so I didn't realize that those two questions were identical. The two question types could be identical.
Right.
So it ended up generating like a question and a follow-up question for us, even though we knew in our heads that those two were going to be identical object types.
So the tool itself didn't fail us, it was our own self.
The tool did the best that it could,
Yeah.
and it was the fact that we were giving it JSON example rather than JSON schema, which meant that it was not able to connect the dots. It was sort of out-of-band information, right? We knew in our heads that was going to be the case, but there was nothing they could look at from the example to infer that was reasonably going to be the case. And it wouldn't always be the case. Sometimes you would have a question which would have a nested question type that was fundamentally different.
Yeah.
Exactly. So they can't make that assumption. So they're correct. The tool is correct to make them separate. For our purposes, it meant just a little bit of manual editing after the generation of that, which is, again, net time save. So still into it.
Lots of hours saved. So let's say that we're going to jump into another hackathon. After we win this one, we're going to jump into another one in a month and have to do this again. Let's walk through, as though we've forgotten everything, how we would recreate what we did here.
You mean specifically for like the JSON stuff?
Yeah.
Okay.
Specifically the JSON stuff, not the whole
I
lot.
was going to say, well, where do you want to start?
All right, let's jump into the code.
Okay, let's do it.
So here we are on the JSONSchema2Pojo website. Why don't you walk us through a little bit how we started here, Stuart?
Okay, so what we see on the left-hand side there is the JSON example that we had built that illustrated the 3 kinds of questions we were going to support in this chat UI. And then we did a little bit of configuration on the right-hand side. So the right-hand side is largely some configuration that explains sort of the context of where your objects are going to be generated into, and then sort of some nice options you can turn on and off. So in particular, we specify the package name here, which is sort of going to correlate to where we put these within our project. We have to tell it what the base class name should be because there's no sort of base label on this left-hand side. All the other class names will be inferred from the keys in this set. And then this is sort of what we were talking about a little bit earlier, the source type. So rather than having an explicit JSON schema here, we have to inform the tool that we are just giving a JSON example, and it will have to do the best it can with generating those classes. So again, a bunch of options you can turn on and off depending on your specific needs for those generated classes. We didn't need a lot of extra fancy stuff. And then when you generate the sources, you get a zip file, I've expanded that somewhere else. Where are we? In the zip file. So these are the classes that were generated for us. So not much to see inside these. As I said before, the relationships will be correct within these classes. We'll look at that in a second. But notice right here that there's like a response and a response underscore type, and a question underscore type. So those correspond to objects that in different parts of the JSON hierarchy that have the same key. Shit.
We'll pause.
Okay.
Sorry for the break there. We just found out that we won the hackathon.
Crazy.
That was a joke earlier.
Yeah,
we actually won.
Yeah.
So we're gonna finish this up really quickly and then go congratulate our team.
Yes. Yes. Wow.
So Stuart, here we were with the
Yeah.
objects.
So these award-winning objects. Yeah. So so yeah, you'll see there's like a question and a question underscore type, and that's because there are two parts of the JSON structure that use the key question. But this generator, as we've described before, could not know that those were really meant to be the same object type. So it generated two different versions of the same class and just depended on an underscore to one of them to differentiate between them.
So there's no significance to the underscore.
The underscore is, yeah.
Standard annotations, there would be a significance. But here there's not.
Yeah. Here it's just to delineate like one version of the question from another version of the question. And again, you would see if you looked at the question flow class, which question was used in which place.
Right.
So we can take a look at that in Android Studio. So these are the models that we actually ended up using, these four right here. So you can see we've removed the duplicate response and question types, and then we are just reusing the question type in both places. So if we look at something like the question flow, this is all generated code. We didn't write any of this, so we have a list of questions, we have a version of the specification. If you look inside the question type, that again has like a follow-ups, it has a string prompt, it has the response information, and the string that we send to the server. And then if we look inside the follow-up type, this is where we get back to like our question type is within the follow-up.
Right.
So you can have a follow-up that contains questions, and this question containing a follow-up containing a question.
Yeah.
That's the part that the generator cannot ever be smart enough to figure out for us. So that's the manual patching that we did. But that's it. All of the rest of that was pretty straightforward, very quick, very easy to edit.
Excellent. And then, but there was one more time when we ran into a mismatch in objects. When we were, you want to talk about that?
I don't remember it.
Remember when we were, so we were like in chat activity, and then we were going to pass a bit, we had to...
Oh, right.
Yeah.
Yes. That was for an older version of the specification, where the connection between question and question underscore was way more obscure, because at the time they were named datum and follow-up question. So it wasn't like we got two very related names.
And then the JSON changed.
So we changed the JSON, so that at least the manual edits we'd have to make would be a little bit easier to repeat than, so datum is question and follow-up question is also question. Now it's just like, get rid of the underscore version and replace that with the So
lesson learned, if you're having problems with data not matching up, you can just change your JSON to make it easier for the schema to understand.
This was the case. In this case, it was an example where we had out-of-band information that we hadn't properly encoded in our key information.
Right.
It is a little bit unfortunate.
Making it up.
Yeah, it's a little unfortunate that the key is used to infer the type, absolutely. But again, there's no way you could do that otherwise. So you're restricted a little bit based on the keys you're allowed to choose. If you want two objects to be the same type, they have to have the same key.
Right.
But apart from that, I'll do that.
So any other tips that you'd share with the future version of yourself when apparently we're continuing on this project in 2 weeks? Any tips you'd share on JSON2Pojo?
That's a really good question. I would say no. I would say I have a pretty good understanding of how the thing works. I have a pretty good understanding of the limitations. It would be fun to play around with JSON schema.
Yeah.
I've never written JSON schema. I've seen it used in some open source projects that I contribute to. But I haven't ever worked with it myself. So that would be like a fun little kind of technical challenge.
Mess around.
Yeah. The other thing I've like sort of an open question I've always wondered about with generated code is it's never going to be smart enough, right? So, for example, our question types were all defined as strings in the JSON specification.
Right.
And really, we knew they were going to be an enumeration. There's only 3 allowed values.
Yeah. And so later we had to go back and make them into like options. So that involved the whole different
So again, maybe that's something that could be solved using schema. Maybe not. I'm not 100% sure without some investigation, but I'm sure that's never 100%. There's always something you're going to want to tweak and change a little bit, even if it's just adding sort of helper accessor methods. So you can, query against that object in a slightly more domain-specific way.
So does that give you hope that we're really not that close to AI taking all of our jobs?
I keep hearing this whole, 20% of programming jobs are going to be gone in 20 years.
Yeah.
I don't know how that's going to happen. I don't think that's a real thing.
Yeah.
As someone who's in the field, I refuse to believe it.
It's not like computers are as smart as the tools, so.
Well, as smart as they get, they're going to keep needing humans to make them even smarter.
Yeah, intuition is a thing.
Yeah, and ultimately, like producing products for humans. I don't know that AI is ever going to get to the point where it can just replace us in that.
I hope so. Awesome. Well, thank you very much. We're going to go celebrate with our team now. Thanks for watching.
Cheers.